Hello everyone, welcome to Continuent's next webinar, Basics, the Power of the Connector. Before we get started, just want to let everyone know we'll be recording. Additionally, you may grab the handout from the GoToWebinar control panel. Additionally, if you have questions during the presentation, please type them in and either myself or my comrade Gilles will answer your question either during the session or after we end, we'll send out responses. So without further ado, we have a lot of material to cover today. We're going to start out with a very quick refresher, and then we're going to move on into the more enjoyable, detailed technical stuff. Hopefully we'll have time for a bit of a demo in there, and so forth. Also, I hope everyone enjoyed the preview of my screen as we set things up ahead of time. So let's get started. We're going to focus on cluster deployments, cluster architecture, how the connector fits into all of that, and where is the best place to put the connector, and why do we put it in these different places? What are limitations, and what are the best practices associated with it? We'll talk about zero downtime maintenance. We'll switch between nodes, we'll move the master around, and we'll get stuff done without the apps having problems. We'll talk about what happens when we deploy a connector inside of a composite cluster. The fact that the connector is capable of understanding its position within the composite cluster, can talk to all of the clusters, and knows when the master moves both locally and between sites. We'll do that with a demo of a manual site switch. And finally, if we have time, we will deal with Read Affinity, where inside of a composite cluster, we've got the connector doing reads from local hosts and not from the primary site. Additionally, we can look and see how a connector can actually do reads and writes to multiple different data services. That's pretty advanced stuff, and hopefully we'll have time to cover it all. So, first subject, architecture. Again, as a review, this is what the local cluster plumbing looks like, right? We have multiple layers with the connector providing connectivity and fault tolerance. Fortunately, this is the first slide of any real visual interest. I apologize for not showing earlier. We can simply see that we have a summary. And this is the first topic slide. Again, we see the cluster with its replicator layer, manager layer, and connector layers, connector providing connectivity, always sending writes to the master, and potentially pulling reads from not only the master, but the slaves as well. In this sense, we again show that the connector is simply a smart proxy. It takes MySQL native traffic and sends those requests to the appropriate places. All right. So from a general perspective on deployments, we are talking about the volume of connectors we are allowed to use. Why is there a limit? Because the connectors have communications with the managers, and in order for failovers and communications to occur, this happens synchronously. Therefore, within a specific cycle, there's a limit to the number of connectors we can reach and do it efficiently. Other great stuff about the connectors, they do not have to be all set up the same way. You can have different connectors providing different types of services. Some can be configured to use proxy mode, some can use smart scale, some can be set up to be read-only, and so forth. Frequently we get asked questions about how big should a connector host be? And that, of course, depends upon the number of connections, the volume of traffic that you intend to support. So the various different modes of the connector require different amounts of memory, and there's more in that in the documentation. We like to use HA proxy software to create high availability in front of the connector layer, which we're going to cover shortly. And finally, for doing deployments, if you're going to use DevOps, Puppet, Chef, or Ansible, we suggest to use INI instead of staging. Let's keep going. So today we're going to talk about 3 different topology types, where to put the connector and why. So number 1 is placing the connectors directly on your application servers, where the application would be configured to talk to localhost effectively. Number 2, create dedicated nodes for the connectors, minimum of 2, so that we have high availability, and some form of load balancing is going to be required. Again, HA proxy software, a physical load balancer, whatever may be the case. Finally, if you wish, you can even put them directly on the database servers themselves. Again, same rules apply, minimum of 2. You need some form of load balancing. Something to note here is there's nothing stopping you from doing all of the above. You could theoretically install connectors on the database nodes, on dedicated connector hosts, and on the application servers. So all 3 could be done simultaneously. So let's look at some pictures. First off, in these architectures, there is an assumption that your application layer is inherently fault tolerant because you have placed a load balancer of some sort in front of your application, say web servers, app servers, whatever. So we're leaving it to you to provide fault tolerance at your application layer, and that's business as usual for most every one of our customers. So the first topology is to simply install the connector Java process right on the app server. Therefore, if for whatever reason there should be a failure in the connector layer here, then this load balancer should note that the application is no longer functional and simply remove it from the pool, and that's that. And this is, of course, the cleanest and simplest because the connectors simply take the place of MySQL for the application. Application talks locally to this process, which is very fast. It doesn't need the network interface. And then we then do what we do with the connector, sending the traffic to the appropriate spot in the cluster. Let's see. So we did just talk about the fact that we assume load balancing at the app layer. For the sake of brevity, considering there's a lot of material in these slides, I'm going to discuss a lot of what you can read when we see the visual pictures and skim through these, and you may use this in the future as reference material. And certainly don't wish to go through this twice. So one of the interesting things to note is that, again, we really prefer that you start to consider using dedicated nodes for the connectors if you have more than 20 application servers. Performance will be better, control will be better, a lot will be better. So let's look at that next. Here we have a very similar design from the front, looking in, your load balancer, your application servers. But now we're going to deploy a hardware load balancer, and your application servers will request database from the load balancer. The load balancer will have a pool of dedicated connector nodes to choose from, and the connectors will function as designed in the back end, as we've already discussed that behavior. So this can be contrasted with something that looks more like this, where we have the same dedicated connector nodes, but you are not using a hardware load balancer. Instead, you've installed the HA proxy software directly on the app servers and configured each of those instances to know about all of the different connectors. So it functionally works the same. HA proxy software is free, mature, and stable. So many of our customers prefer this. It's very easy to configure and maintain. So we find that this topology is typically the best practice and the most cost-effective. We recommend this one the most. Certainly, if you have the money and resources to use hardware load balancers, by all means, that's wonderful. But we find that this is certainly very efficient on the budget. Okay. Lastly, the same thing applies. We can place connectors directly on the database nodes, and you will need the same HA to provide high availability if one of those connectors should go out, right? Either a physical load balancer, a hardware load balancer, or again, the HA proxy software. All of these little extra lines in here, they demonstrate one of the drawbacks to placing a connector directly on a database node. And that is, you've now converted your database node into a traffic router in addition to being a database node. If any one of these application nodes should create a session, say, to a slave node down here, then that slave node, if it's routing a write, that write must be sent to the master, which means the request will come into the node and go back out the node, and then the reply will come from the master to the connector and be sent back to the application server. So what that does is increases the traffic dramatically on the database nodes. Something, especially if you're doing read-write splitting, is not necessarily what you want to do, because, for example, if I, by luck, get connected to the connector on the master, but I'm configured for read-write splitting, that means that request will hit the master node, get sent to a slave node, come back, and be sent back as a response. Clearly, this is inefficient. That's why it's really much, much better to put the connector nodes outside the database instances, whether you put them in the middle or you put them on the app servers. Okay, so those are the basic topologies that we recommend and why. Let's keep going. So how do we use a cluster to keep things moving when we do maintenance? We can do things like rebooting nodes, upgrading operating systems, restarting MySQL, any sort of administration that you need to do. Let's see how we can make that happen easily. So the switch. The switch is the heart of making this happen. What we do is we just simply take the master role, move it to another node. So the idea is we'll perform maintenance on non-master nodes, and then when we're ready, we switch the master role to another box. You can pick what you want to switch to by specifying the target, or you can let the cluster decide by just typing switch. One of the key things to remember is to make sure that the target node is caught up 100% with all transactions before you switch to it. If you manually invoke a switch, the cluster thinks you know what you're doing and will let you. This slide is for your reference. I am not going through this in detail, but these are all of the rules that the manager uses to decide which is the next appropriate slave to use for a switch. It also uses these rules for failovers. So this is really good information to read through about what it will skip, what it will use, and how it evaluates the state of the slaves. So to do a rolling maintenance, we do it one node at a time, starting with the slaves and ending with the master. Documentation is listed in the presentation slides. A switch operation, as compared to a fault failover, will wait approximately 5 seconds for anything that's in flight to complete. You can tweak that with this setting. if you want to. Depending on the connector mode that you are in, the application will either experience a hang or a disconnect. So bridge mode, because you're effectively on a TCP pipe directly to the MySQL server, when you switch, you're going to have to be disconnected. It's just the way it is. And we will automatically reconnect you to the new master when the application makes another request or retry. We wait until that happens, and then we make a new connection to the appropriate server. If you're in proxy or smart scale, in other words, any non-bridge mode, if you're idle, when things happen, we will just reconnect you same way when a new request is issued, but you will experience a hang. You will not actually be disconnected and get an error back. As an added bonus, if you were doing a long-running read, not wrapped in a transaction, then we will actually retry that read upon reconnect. So writes and other things we'll have to retry from the application perspective. These are very powerful features, and it's what enables us to do these sorts of moves in a healthy manner. So let's look at that in a picture. So in a 3-node cluster, for example, you shun the first slave, do whatever your maintenance is, bring the thing back with a welcome, and if something should happen, you can always reprovision it. Once that's all worked out, update any remaining slaves, finally issue that switch command to promote any one of these already completed slaves to a master, and then finally you can upgrade the old master, which is now running as a slave. This is what we call rolling maintenance. Okay. So, what time? 12:17. Yeah. We can very briefly. Here we are. What you see in front of you is actually 2 clusters, a composite cluster. The top 3 is east, the bottom 3 are west. And so what we can do is demonstrate this rolling maintenance activity. We are currently logged into MySQL. Let's get out of there, and let's get into ccTRL. What is the current state of the cluster? So DB1 is the master, DB2 is a slave, DB3 is a slave. Effectively, we can simply assume that we have completed whatever we need to do on the slaves, because what's really of interest here is switching the master. You can shun a slave and bring it back. And if you shun a slave and you're doing reads from it, the connector will just repoint you to another slave or master. So that's not really a big deal. The big deal is the writable master. Let's deal with that. So here what I'm going to do is I'm just going to log into MySQL and figure out what host I'm reading from. So right now I'm reading from DB2 and I'm writing to DB1. So the key is, if I'm in the middle of doing this select and I switch, what happens? So here I'm just going to type switch on, and this is going to take the master role off DB1 and put it on DB2. So go, oops. Always something during a demo. So what we just learned from that is that we can't switch if, for whatever reason, the slave is not available. Let's see if it is. And now we should be able to switch. And let's get back into here, and that, and that. So if you notice, I put in a read request for an update, and it is simply sitting there and hanging. That's exactly what would happen to your application. As soon as we have switched over to a slave, notice in the left window, we just managed to put the new master online at that very instant in time, long before we even reconfigure the slaves. Our read goes through. And we've clearly chosen DB3 as the master. Let's go take a look. And there it is. DB3 has become the new master. So that's a demonstration of what happens to your application during a rolling maintenance activity. Now, let's talk about how the connector routes traffic inside of a composite cluster. We looked at what a local cluster looks like earlier, which is just one of these data services, an app stack, a connector, and nodes. Well, let's add another one in. We've got the same 3-node cluster, connector, and an app stack, but notice that the quote-unquote master of this data service is got a different color. It's orange, and it's labeled relay. We do this because the relay is responsible for pulling traffic from the master data service in a composite cluster. Replication flows one way. So writes will always occur on the master in the master or primary data service. That means the primary cluster. So one of the things to note here is that all connectors know about all clusters. And if I happen to say, let's call this California, and let's call this, London or New York. Here, let's call this California, let's call this New York. So now I've got two clusters, one on either side of the country. And so if I have a connector in New York and somebody sends a write to it, it's literally going to send that write back to California. So these sorts of setups are frequently designed for disaster recovery activities, where you will move your traffic to the appropriate site. That's one possibility. Also, this works really, really well in globally distributed applications where you have very light writes and heavy reads. So connectors can actually be configured to read locally. That's called affinity, and we're going to catch that shortly. And so one of the great benefits is if you have a global load balancer that's directing traffic maybe through DNS to an application stack in New York, and it's a read request, then that connector can route that read request to any one of these 3 nodes, and things will get read quickly and easily from here. The risk, of course, is that there's potentially stale data by a second or two if it were to be being replicated across a WAN to get written to the New York side. So these are things you need to take into consideration when you use these things. Additional uses would be to potentially have a fault-tolerant reporting cluster in a local data center. If you had both of these clusters in a single site and you called one production and you called the other one reporting, then the best part is that the reporting cluster is highly available and it pulls information in a highly available way from the production cluster. So these are other uses for creating composite clusters. And you can have multiple, more than 2 clusters within a composite cluster. You could have 3, you could have 4, you could have 5. So I could have one locally for reporting, put another one in a different region for geolocation, and so forth. It's a very, very powerful composite cluster of clusters. So again, by default, all traffic will go to the master node in the primary cluster. If you enable read-write splitting, we can then start directing traffic to the slaves. So for the demo, we wanted to show what happens when you switch not between local nodes in a local cluster, but what if you move the actual master role from one site, so take this green master and make this relay turn green, make that the new master, and make this current master orange and turn that into the relay. So everything flips around. So what happens if we do that? So let's go check out the screen. So if we note here, let's go into cctrl-multi, which is what allows us to see the composite cluster. And inside the composite cluster, I've got a composite master that's east, that's the top 3 nodes, and a composite slave cluster that's west, that's the bottom 3 nodes. If I were to do the exact same test on a west node, let's talk to that connector. And let's find out where I am writing to. Notice I'm writing to DB3. That's the master over here. If you remember, we switched over to it. So the master is DB3. Therefore, here over on west on DB5, when I do a write, I'm being directed to the other cluster entirely, DB3 over in east. So if I switch between clusters, where should we land up writing to? Well, chances are it's going to be DB4 because right now DB4 is the relay and will probably turn into the new master. Let's see what happens. So I'm going to do a switch. It's the same switch command, but I'm doing it from the /global composite cluster perspective. So here it's telling me it's picking west as the place to go. And if I run that command, we are pausing, we are hanging, we are waiting. And notice, as soon as I make that switch happen, I now execute on DB4 as anticipated. And if we look again at DB4, DB4 is now the master. If we look over here on east, DB3 has become the relay. So that concludes the demonstration of how the connector handles site switches. And of course, failovers work the same way. If it automatically were to fail over inside of a local cluster, that works the same way. Please note, failing between sites is never automatic. Failing between sites is always a manual activity, either using switch or failover. We do this deliberately because we want to make sure that you are not flapping between wide area sites. We all know that WAN connections can possibly drop, and we don't necessarily want a disaster to occur within your cluster if you haven't rigged things appropriately. Everyone uses these differently. All right, let's talk about affinity. So affinity is read-write splitting with a specified source. So if I were to make a connection to this connector over here on the right side, the one say is in New York, that connector can be told to prefer the New York slave data service for reads as opposed to sending everything back to the source. This is what allows us to get those reads locally instead of remotely. We do this in a number of ways. We can typically use the user.map file and we define the affinity. So a normal user.map entry gives a username, a password, and a service name. For a composite cluster, that's always the name of the composite cluster. And then we can specify an affinity, west. or east or whatever we choose. So note that this uses a fact that we learned previously. Not all connectors need to be configured the same way. Therefore, on connector nodes in the west, you would edit the user.map file and place the keyword west in those user.map files. On the east nodes, you would edit the user.map files and place the keyword east for the name of that service. So we need to differentiate the configurations on each host to tell them individually what they want in terms of affinity. You can also specify that as part of the database connection string. And here we can specify an affinity. And of course, affinity is really only useful if you've enabled read-write splitting. If you haven't, then affinity is meaningless because it would all be reads and writes directly to the master. So here's a JDBC example. You can also do it using the TPM option connector affinity, which hard sets it globally. Please note that there are some limitations when you specify connector affinity in bridge mode. Anything that you might have specified using quality of service within the connection string, they're ignored. So you can't do this any longer if you specify connector affinity. Okay. So lastly, how can the connector rather support multiple different clusters? So here in this example, we have a standalone single cluster. Maybe let's think about that as a reporting cluster or some other resource separate and distinct. And here we have a composite cluster. So it might be that there's some application service sitting somewhere over here maybe that really needs the ability to talk to both. I've installed the connector on that box and now I just want to be able to get access to this other cluster resource. Well, we support that. So what we do is we edit a single file called dataservices.properties. And when you do that, you can then define multiple services. So here is what the default looks like for a composite cluster. Notice that global is not listed in this file. The tools are smart enough to know how to define all of these things without the composite service name being in there. So if we simply add in the name of the service and the host names for that remote cluster that you want to talk to, you can do that. You restart the connector, and the connector will then be able to talk to that. Now, the key is that once you have added this information into dataservices.properties and you've restarted the connectors, you need to know how to tell the connector to choose the service that you want to talk to. So the key here is that you use the user.map file again. And so previously, for example, we had the composite cluster global and an affinity of west for the Chris user and east for the Eric user. And now we create a new user called Matt, and its service name is reporting. And so when you make a connection as user Matt through the connector, it's going to bring you over to, in this case, the master of the reporting cluster. Now, please note that there are some limitations here. You cannot have multiple duplicate usernames. So I can't have Eric twice, can't have Chris twice, can't have Matt twice. So you need to define specific names. For example, maybe you'd call Matt reporting. Right? And if you connect as the reporting user, it's going to bring you over to the reporting cluster. So do we have any Questions, queries, or posers? I don't see any on the panel. Then, without further ado, in summary, we have reviewed various topologies. We have explored zero-downtime maintenance. We have looked at site switches and how the connector treats them so very well and smoothly. We've talked about read affinity and how you can improve read performance across geo-distributed sites. And finally, how the connector can be configured to talk to multiple clusters for writes. Thank you everyone for attending. If you have any additional questions, would like to get in touch with us about sales or support, here are some additional resources. Email us, sales@continuent.com. Check us out on our website, continuent.com. And we hope you have an excellent day. Thank you very much.